Hello. So, thank you for tuning in again. This is Science with Chris. So, prepare to get wowed. So today, super interesting. I'm going to be talking to you on a paper that was recently published in Nature, and this came out January 22nd, 2015. So this year. The title of it is "A New Antibiotic Kills Pathogens Without Detectable Resistance." If you saw in my previous video in regards to phage therapy, there's a huge issue with bacteria becoming resistant to more and more types of antibiotics. MRSA is an example with methicillin-resistance. We have vancomycin-resistant. We have all these antibiotics in our arsenal, but they can't kill the bacteria anymore that are killing us. So this is a really interesting approach now. So phage therapy was using viruses to then kill bacteria, but now we have a new antibiotic which we can try and use to then kill specific types of bacteria. So a little bit of backstory. So when we talk about labs and growing bacteria, we only can grow so many different varieties of bacteria. In fact, we actually can only grow 1% of the bacteria, where 99% don't work in a lab. So we have this huge untapped resource. But at the Lewis lab, in this article, they create this new technique called iChip, which pretty much is digging through soil, finding one bacterium, putting it between two pieces of really thin paper, putting it back into the ground, and then letting it multiply on the piece of paper. And then they take the paper out and they analyze that bacteria for specific antibiotic-resistant or antibiotic proteins that it makes. And they were able to find one really interesting. It's the name of the bacterium is Eleftheria terrae. They named it, and it's part of the Aquabacteria family. And this bacteria is a gram-negative bacteria. And so now I'm going to kind of show you, break it down like gram-negative, gram-positive, just a very brief, not too crazy kind of understanding. So we have gram-negative, and for gram-negative, we have peptidoglycan, which is this shaped thing right here. So I labeled it down here. And for the peptidoglycan, for gram-negative, there's also this extenuating structure that goes above it, so that you can't really get in contact with peptidoglycan, which will be important in a little bit. And you also have gram-positive, now that has peptidoglycan available on the surface, and then I label these little stars, and these little stars refer to teichoic acid. Not super important to know that, but it'll become more important as I go on to this paper. So reading through this paper, they found this bacteria that creates this new antibiotic called Teixobactin. Let me write it up for you guys. Teixobactin. Okay. So it's called Teixobactin, and the bacteria Eleftheria terrae, which they found, was a gram-negative bacteria. And the Teixobactin, which is the new antibiotic they found, attacks gram-positive bacteria. And it specifically attacks them with their peptidoglycan and teichoic acid area. So it attacks this area right here. And what's interesting is when the gram-negative bacteria makes it, it can't hurt itself with it because it doesn't have the same structure on the surface. So they found this new antibiotic and they tried it and tested it in mice. And one of the most potent antibiotics we have currently on the market is vancomycin. And they did tests on it, which I don't want to show too much, but the tests kind of look like this, and it was crazy. It shows that vancomycin Teixobactin work very similarly. So the last thing I want to say about this paper was the downstream effect. So what the problem is that usually bacteria can confer resistance to certain antibiotics. And so Teixobactin isn't a save-all, first off. It only works on gram-positive, like I said earlier. And so that's like staph, which is like MRSA, and C. diff. So those are like two common ones that are gram-positive. So Teixobactin will work on these two. And the other issue is conferring resistance. Now, Teixobactin is really interesting because it attacks a certain part of the membrane, but not really a protein within that the cell makes. So, or within the bacteria makes. So the bacteria make lipid, make cell membrane through other organic molecules. So it can't really get rid of this pathway. So Teixobactin is, from what the paper is saying, almost it's an unbeatable antibiotic, at least for now. So this is really interesting, and they did another study also in antibiotic-resistant staph, and they were able to see that after 28 days, which is I don't even know how many thousands of replications, they were still not able to get resistance to Teixobactin. So that's a really good thing because resistance is one of the huge issues, especially in my phage therapy. What I think the take home of this paper is, so we have one more antibiotic in our arsenal now that is supposed to work very well and could be another last resort. But this should not be something that we should just rest ourselves on. We need to kind of think more proactive, more preventative care. So though we have another tool, we should not be using it freely like we have in the past with other antibiotics. I still think that we should be looking at other methods. Maybe this iChip method will be great for determining other types of bacteria out there that will produce other antibiotics. So we're constantly fighting against this bad bacteria in our body. But thank you for listening to the video. If you have any questions, I'll try to answer those as best as possible. The link for the paper will be in the description, and click here to subscribe. Thank you so much. Have a great day.